Garden State.
A little bit.
Still 45 minutes away. 45 minutes? Yeah. Yeah, I don't get out much.
Do I need to hold an eraser to throw it?
Okay, so today's our last lecture of this class. It's by Professor Lipcius from Virginia Institute of Marine Science. So he will talk about the big data for marine species to achieve conservation goals.
Okay, thanks, Junping, and good afternoon, everybody. Let me mention that I'm going to try to keep this informal, even though it's a PowerPoint. So if you have any questions as we go along, please just ask. And then, first of all, how many of you are math majors? Computer science, physics, biology? All right. Token biologist, here we go, okay. Any other majors? No? Okay. So in keeping with this seminar, I'm going to show you some examples of the importance of big data and their analyses, and really how complex the data are now that we, in marine science and marine conservation, biology in general, absolutely need to have sort of collaborative efforts with mathematicians or computer scientists or statisticians to really understand the patterns. What I'm going to do, I just selected a couple case studies. So I've been a professor over at BIMS in the School of Marine Science for about 26 years and worked on various marine species, from what I'm going to talk about a little bit here, oysters and blue crabs, to spiny lobster, queen conch, Nassau grouper, really a range of species. But I selected these two to show you a couple things. One is, for the blue crab, what you'll see is how you collect data in a relatively simple fashion, and then really the problem comes in the analysis of the data, and particularly the statistical analysis. And the data that I selected is primarily spatial, although I'm going to show you time series of data. The analysis, the complex analysis, deals with spatial data, okay? And then I'm going to go briefly touch on the oyster. Most of the talk is just going to be on blue crab, motivating the blue crab, why it's important, and so on. And then touching on the oyster, because some of the technology that we're using with oysters to look at patterns in space are quite complicated, quite advanced, so like multi-beam sonar and so on. Okay, so first let's go ahead and start. And by the way, so down here on the lower right, I assume all of you know that's a blue crab in the middle, or you made the assumption. So that's a subtidal oyster reef on the right in the Great Waikamaco River. It's a restored oyster reef. It has about 1,000 oysters per square meter. It's the first really major successful oyster restoration in the Chesapeake Bay. There are roughly, we estimate, about 200 million oysters on that reef. And then on the left is an intertidal reef. So this one's in about 10 to 20 feet of water. The one over there is intertidal. And again, that's an oyster reef with a little marsh hummock on the very tip of that. And this is what we think the bay looked like in John Smith's day, before the late 1800s, that there were massive intertidal reefs along the shore. The Native Americans would actually harvest those, as well as subtidal ones. And they're quite important because they filter the water column, they provide refuge for a range of invertebrates and vertebrates. And also, they're obviously economically important. But we have just absolutely devastated oyster reefs. They're at less than 1% of the historical levels in the 1800s. By the early 1900s, we'd already caused substantial declines. So there's a major effort underway to restore oysters. President Obama signed an executive order in 2009 to restore 20 tributaries in the Chesapeake Bay by 2025. We've since revise that to 10 tributaries by 2025. So, but anyway, so I won't talk a lot about that. I'll show you a couple slides at the very end on oysters. So I've talked quite a bit to math folks and so on about oysters. Okay, so let's just start off with the blue crab. So first of all, well, why should we care about the blue crab? The blue crab is a major predator in the bay. What I'm showing you here is the food web of the blue crab. So that's the food web of the blue crab in the Chesapeake Bay. And all these species here are predominantly finfish. You also have sea turtles that eat them. These are blue crab adults. Those are blue crab juveniles. And then they eat a range of species: soft-shell clams, hard clams, oysters, and other non-commercial bivalves, clams and such, and marine worms, and just various species. They're very important. They also cannibalize each other, which makes for a very interesting demographic model. The dynamics of blue crabs or any cannibalistic species are actually quite complex. So they're a key member of the food web. In Chesapeake Bay, we estimate that there are anywhere from 200 million to sometimes over 600 million blue crabs. And at times, the very smallest juveniles can be in the billions. So they're everywhere in the bay, from fresher waters all the way down to the saltiest waters. The blue crab is actually of tropical origins, meaning evolutionary origins. It actually evolved initially in the tropics and then slowly expanded its range up to our estuaries such as Chesapeake Bay and so on. And it continues to expand upwards even to New England waters at times. Okay, so that's why it's important ecologically. And then in terms of the economy or commercially, it's also quite valuable. It's been fished basically since the early 1800s, and then more commercially since the late 1800s. So up here, I'll just give you a little bit of a... So the trot line is basically, so since the 1870s, the trot line, you can barely see it. It's a little line here, and it has little hooks. Have any of you ever gone chicken necking for blue crabs? Okay. Well, that's effectively what they do. They put a little hook with some bait right on there, and it's spaced out along this long line, and then they just move the boat along and then just put a net underneath and get the blue crab that's there. This is one of the primary ways of harvesting way back, and they still do it in Maryland tributaries. The dredge fishery, which was closed in 2009 because of the decline of the blue crab, basically puts out a dredge, and I'll show you an actual video of that a little bit later. That's also how we sample it. But anyway, that's just dredges the bottom in the wintertime when the crabs are buried in the bottom. That was in effect for over a century. The crab scrape, what this is, it's actually like a net without teeth in it. This one has teeth. You can see sort of the little teeth down here. This one doesn't have teeth, and it's just dragged in seagrasses and seagrass beds where there are a lot of smaller crabs, and they catch them there. A lot of the crabs they catch from seagrass beds actually end up in shedding operations. So these are shedding tanks, and what they do is they'll catch it. You can actually tell, back up, the crab, since it has an external skeleton, it has to cast the skeleton off to grow. And it does it periodically. When it's young, it does it once every week or so. When it gets older, once a month, once every few months. And what it does is it casts off its skeleton, it takes in a lot of water, sort of inflates itself, and then hardens the shell. And then over the next month or so, it'll actually, the muscle in there will only be in about half of the shell, and then it'll eat. As it eats, and it expands into its shell. And so that's basically how a crab grows. Now you can tell when it's really close to molting by looking at its little swimming leg, and changes color actually as it gets ready to molt. And what the crabbers do, they'll go here and they'll catch the crab, and each crab they'll put up to the sun take a look and see from the color if it's getting close to molting. If it is, then they'll put it in the shedding tanks. And while the men typically are out doing the scraping, the wives are actually, and kids are monitoring these round the clock. Because as soon as a crab molts, casts its shell, they'll grab it and put it in a freezer or refrigerate it to keep it from hardening. And so if any of you have eaten soft shell crabs, that's what you're eating. You're eating crab that's immediately molted. It's very clean. You can eat the whole crab, except for the gills. And you have to keep up with it because the hardening occurs over just a couple days. So it happens very fast. It becomes leathery and then hardens. Also, after they harden up, then they're voracious. They haven't eaten in probably about 2 to 3 weeks. And so if you leave them in there, and they'll just attack every other crab that's in there and eat them. So they're literally watching this, checking these like every couple hours, around the clock. It's tough. On the good side of that, during what's called the peeler run, which is usually in the late spring when the crabs are primarily molting, they can make probably $20,000, $30,000 a month selling those soft shell crabs. So it's quite lucrative. If you go to the store, you might pay anywhere from $3 to $5 for just a single soft shell crab. Quite good. The main gear, though, that's used is the pot, the crab pot. It came into effect in 1928. And actually, step back, the whole shedding operation was actually started by a VIMS faculty member back in the early 70s. So, okay, so what's the value of this? So that's all the fishery. There's a lot of gear that goes after the crab. The blue crab is the world's most important single species crab fishery. It exceeds Dungeness crabs, king crabs, all of the crabs. The only one that comes close is actually the blue swimmer crab from Asian waters. In the Chesapeake Bay alone, its value, it's called dockside value when they bring it in, it's anywhere from about 50 million to over $100 million annually, which then translates economically to about 300 to 400 million for the national economy. And that's just in the Bay. That's only in Chesapeake Bay. Okay, so very, very valuable commercially and as well as ecologically. Okay, so what's happened? Here I'm showing you just a time series. So I'm going to show you a few time series of what's happened. So this is basically motivating why we need to start looking more closely at big data. So this is the number of pounds that are caught annually in the Chesapeake. Virginia, the Potomac River is a separate management authority because it basically, one shore is Maryland, the other shore is Virginia, and back in the mid-1900s they were actually shooting each other so they had to form a different commission to sort of regulate the Potomac. But anyway, the tonnage that's landed every year is from about 120 million to the lowest values we've seen now, around 40 million pounds. That translates, you multiply it by about 3 to get the crabs. So back then we were catching about 360 million crabs, and now we're catching about 120 million. So it's a substantial decline. Now one of the interesting things is economically the value of the crab has increased so that the actual total economic value has remained, it's declined a little bit but not as much as the tonnage. And in fact the crabbers sometimes tell me, so VIMS is, again, a little aside, we're the mandated state institution for fisheries research. So whenever questions come in for the blue crab, they're basically targeted to me. And one of the interesting things is that the crabbers have told me that they don't want us to do things to get the population back up very high, because then the prices will go down and they'll have to work harder for the same amount of money. So it's kind of a real interesting trade-off. Okay, so this, the decline down here, so basically caused some changes in the regulations in 2009. We saw a slight uptick then. But then let me show you, so this is landings data, it's fishery data, and quite often that's not reliable as an indicator of what the population is doing, because there are all sorts of biases in that kind of data. And so the next question is, well, what is the population doing, okay? So now I'm going to start giving you some of the background on the big data that's collected, that we collect annually. So let me take you very quickly through the blue crab life cycle. So this is Chesapeake Bay. It's a little hard to make out, but it's the James River, the York River, where we are down here, the Potomac, DC, and so on. And what happens is, because the blue crab is actually a tropical marine species, meaning that it evolved originally in the tropics in high salinity environments, oceanic waters. The larval stage is very susceptible to low salinity, as opposed to the juvenile and adult stages. And so the larval stages, that's these, they have to go off and develop offshore where we have high salinity. So what the females have to do, they, from throughout the Chesapeake Bay, the females, after mating, migrate down here to the lower bay, and that's a female right here, and that's an egg mass, a couple million eggs right there. That's a young mass. It takes about 2 weeks until they hatch out these larvae right here. Okay, and those are about the size of a pinhead, a little smaller than that. And then they float out here for probably about 3 to 4 weeks. And after 4 weeks or so, and they molt out there about 7 times, then they metamorphose into this. This is the size of a pinhead. That's called the megalops, or the post-larval stage. That post-larval stage is a stage that has to come back into the bay to the nursery habitats like seagrass beds. Okay, so if we don't get any of these, we have no juveniles and adults the next year or two. So it's susceptible to what's going on out here. I'm not going to talk much about it, but one of the big areas that we're looking at is trying to link up atmospheric and hydrodynamic models to try to understand better how global warming and other changes in current systems are influencing the reinvasion of that, but I'm not going to talk about that very much today. Okay, so these post-larvae, then they come in and they're affected by currents and they settle in seagrass beds or shallow habitats. And then they metamorphose from this into this. That's a very young juvenile. That's probably about a couple millimeters in width. And these also live in the seagrass beds. They live there for about a month or so, all the time growing, molting. And then they start to spread out. They start to go up the tributaries, up bay, and basically repopulate the whole bay. They have to watch out for the adults. That's actually an adult cannibalizing a juvenile. As I said, they cannibalize each other. And then after about 2 years, they mature, and the males and females, they mate in the tributaries. And then the females undergo this mass migration, back down to the lower bay to hatch out, okay? So it gives you a sense of the complexity of the system. 200 miles across the bay. It spans, because it's sort of a north-south bay, of course, there are big differences in water temperature and so on here versus in Virginia, Maryland versus Virginia, and so on. Okay, so that's where, that's what the population is. That's what we're trying to monitor. And remember, there are anywhere from hundreds of millions to billions to a few billion crabs out there that we have to monitor. So now I'm going to show you, and it's this monitoring that gives us the big data that we are beginning to analyze. So, okay, so next, here's how we monitor. So what I'm going to do, I'm going to start this up. This is a long, I didn't edit this, so I'm going to let this run while I talk. But what you'll see, so let me, okay. So this is the Bay Eagle. This is our vessel. It's about 50 feet long. On here are my staff, as well as a vessel captain. And what they're doing, what we do every year, and we've been doing this since 1990, is we sample 1,500 stations throughout the Chesapeake Bay. So every one of these dots is a station that we've sampled. VIMS does all this sampling in the Virginia portion of the bay, and the Maryland Department of Natural Resources does the northern part of the bay. We actually just finished that, and this is the basis for stock assessment of the blue crab. This is how the fishery and the population is managed over time. It is the only sort of population-wide survey. There are other ways that you can survey, you can trawl and so on. What he's doing right now, this is important, he's actually putting out what's called a YSI meter, and he just took temperature, salinity, dissolved oxygen, and so on at each station. That was a dredge going out, and it's towed for a couple minutes exact. We actually take GPS coordinates at the start and at the end, so we know exactly what distance it's moved. And then estimating that, it allows us to estimate the area that we've sampled, and that with a catchability conversion we can estimate the actual density of crabs. All right? So at each station we're taking all this physical data, and then once this comes up, we take a number of, they see Katie and John Olney Jr., the vessel captain, and she's recording things off the GPS and other things. So you'll see in a minute how the crabs are brought up, but what I want to emphasize is that each one of these points throughout the whole bay, we're taking all that information. We also do a couple other things. We actually take bottom type, so we put out what's called a Ponar grab, and that we bring it back up, and we've analyzed the sediment type, mud, sand, muddy sand, hard bottom, or maybe seagrass, rarely. And so again, all this information goes into separate data layers. You should see in a minute how bring it up. We do this from about late November through late March. That's the typical sampling period, and we do it, remember, because crabs are inactive at that time. They're not moving, so we don't have to worry about sampling a site and then going somewhere else and catching a crab that had moved from the other site. It allows us to get a good estimate of abundance. That stuff on there is hydroids. Those are colonies of invertebrates right there. They're all over the bay now. They do very well when you have poor water quality. So it's unfortunate. It's a real pain, too, to sort through. What he's doing right now, he's sort of moving the dredge up and down to just clean it out, get rid of a lot of mud and sand that's in there and so on, and then bring it back on board. It's about 6 feet across. Dredge, it's got the teeth that go into the bottom. They're sort of over here. If any of you ever want to go out on one of our dredge surveys, just email me, and I'll be happy to take you out for a day. It's always this beautiful and nice in the wintertime. Nice, flat, calm seas. Oh, it's great. We'll even provide lunch. So what he's doing now is he's sorting through everything in there and getting, because we have to be very careful about getting all the small crabs and big crabs and so on. So that's why, that's Mike, he's being very, very careful about sorting everything out. That time of year, the smallest crabs are about this big, so you can see them. We don't have to worry about bringing this stuff back to the lab to process it under microscope. And so we're quite efficient at that. What you're going to see in a minute then is some of the data that's been generated. And it's over 25 years approximately of data. And again, for each one of these points, we have the full physical data as well as the crab data. We actually also have what's called bycatch data, which is like we catch things like horseshoe crabs and whelks and other species, but we're not as focused on that. That fishery, so there you see bee crabs, the results, and then we take those back. We actually take all the females, it's primarily females that are down there, there are juveniles in the tributaries, and then we take those, measure them with calipers, and then we actually tag them. and release them. And by tagging and releasing and then recapturing in the fisheries, or when we recapture, we can actually estimate some demographic parameters like mortality, fishing mortality, and so on. Anybody know how you hold a blue crab? This is not a joke. You know how you hold the blue crab so it doesn't pinch you? Okay, you got to hold. You have to hold it by the by the base of the swimming leg. That's what Mike is holding it right now, at the base of the swimming leg. That's the only place where the crab can't reach around and pinch you. Everywhere else, it'll get you. So, anyway. Okay, so. All right, so now this is the data that comes from this. Now this is simplified because what we're doing is we take each one of those data points, we multiply that times the area that we've covered, and get an estimate of abundance in the Chesapeake Bay. And so you can see here, in this case, this is the females, and you can see that female abundances range from 220, 230 million, and these are adult females, down to close to 50 million, quite a range. What's interesting, so these two lines, this one's called a target and a threshold. Those are the two main reference points. If any of you ever get into stock assessment, which stock assessment needs mathematicians. I mean, you have to be a mathematician or at least a biomathematician to work in stock assessment. But these are set by population models, stock assessment models. And the target is where you would like to be. So you'd like to be sort of popping around here. The threshold is what you don't want to exceed. In other words, you don't want to fall below that. And you can see we did fall below that a few times. When you fall below that, that means you have to have some pretty severe management actions. Because at this point, we don't know if the population is going to collapse the way the oyster did. If it's somewhere around here, we think it's buffered from disturbance, environmental disturbance, and so on. Fishing is going on at a good rate. Yes?
So what happened in 2008 to 2010?
Okay, I'll get there in just 1 second. So, so we were up here, and then we were bopping around too close to the threshold. And so the two governors of Virginia and got together in 2008, and they said, okay, we have to do something. The fishery was in disrepair. It was declared a federal disaster. So federal disaster monies came in to help in both enhancing the recovery as well as helping the crabbers out and so on. And they closed the winter dredge fishery. That was the one that catches primarily females in the wintertime. That had been in existence for over a century, so that caused hardship, economic hardship, obviously. But when they did that, as well as other management measures, not just that, we saw an almost immediate response. So all of a sudden, the population increased, went back to exactly where we wanted to be. We had hoped it was going to be around here. And then we had this happen. And despite the management actions. So, okay, so we see that we're still having some problems. So let me show you what's happening with the others. So this was a really good thing. I was about to publish a paper on recovery of the blue crab right around here, and then got this data point, and it was like, oh, geez, no. Yeah.
Is that number for 2014 finalized, or are you still collecting?
Yeah, so you guys can't spread this. This hasn't been, we're about to put out a press release on this. So just, literally, the governor's offices usually like to put out their own press release, and this is not going to be good news. Because we had all this, good news, fairly good, and we just thought this was like a little blip, and oh, good, it's starting to recover, so I started thinking here again, oh, good, I can get back to that manuscript, and then boom, hit this. Okay, so what's happening with the rest of the population? So here's male abundance. Male abundance has been low the whole time. What's the reason you don't see much, you see a little bit of a blip here, but you don't see much because the management actions were actually targeting females. So we wanted to increase the spawning stock. Males are not as important. Sorry guys, they're not as important here. A single dominant male can inseminate probably 10 or more females over a couple of years. And what happens, what's interesting about the blue crab, when the females have what's called the maturity molt. It's the final time that they will molt. And at that point, they go from being an immature female that has an abdomen that's sort of triangular to the one that to this one, looks more like the capital. And at that point, when she's soft, right when she is molted, she's soft like this, she's mating with the male, and that male inseminates her, and he inseminates her with all the sperm that she will have for her lifetime egg production. Meaning she'll put out egg masses 2 or 3 times per year for as long as she can live. And so she stores the sperm, and every time that she gets ready to spawn an egg mass, then she'll fertilize the eggs as they're coming out onto her abdomen. So what that means is that as long as the female gets enough sperm through the mating, and the males can recharge in about 2 weeks, 3 weeks, a large male, so they can inseminate a large number of females. So that's why we didn't worry as much about males. We focused primarily on the females, and that's why you didn't see much of an increase there. But they're low. They're remaining low. Now we are actually concerned that maybe that the females are not getting sufficient sperm from those fewer males to be able to fertilize all their eggs. The other troubling thing was this juvenile abundance. It went up as a response initially here, and then plummeted. And what happened here, several things were happening. We're not sure what caused it, and that's where the big data is starting to come in. This time we had an explosion of red drum. It's a fish. It's a very valuable, recreationally valuable fish and commercially valuable fish, and it exploded that year. And it's a major predator of juveniles. They love to scarf down juveniles in seagrass beds and so on. We think that's why all of a sudden we had such low recruitment, and then because of that low recruitment, meaning the H0, the young of the year crabs, and unfortunately we didn't see much of an increase. So right now the story is not many females, not many males, not many juveniles after all these drastic management measures. And so we're all sort of stepping back. Literally, we just had a meeting of the Bay's technical experts, and we're at a point now where we have to sort of start all over. We thought we had nailed it when we saw the increase, and now it's not there. And again, that's where the big data is coming in. And we can't, at this point, we can't blame the crabbers, because this is the fraction of the population. So remember, I gave you all those numbers of juveniles and adults at the beginning of the year. Let's say there's 500 million total crabs. These are from the stock assessment, what we can take from the population to allow it to persist and also to maximize profit. So where we'd like to be is to take around 25% of that 500 million every year, or whatever it is, 25%. And as long as we bounce around that, we feel we're doing pretty well in terms of the fishery. Well, we're down here. We're actually below the target. We're actually not fishing as high